Hello, and welcome to your first data visualization lecture. All right, so we're going to spend most of this lecture writing code, and that's because this lecture is about the nuts and bolts of actually creating a data visualization. In the next lecture, we'll talk more about the process of creating an effective data visualization and what goes into that. So the first thing that we need to do when using any Colab notebook is we need to run our imports, which you can see I've already done. We're going to use the empty cars dataset from the plot9 package in order to just explore some basic data visualizations. The first thing I want to do is just go over a couple of plots with you, and then we'll go into more detail about exactly how to build a plot using plot9 in Python. Now, this data set is looking at different features of cars, and something I might be interested in is whether the weight of a car has a relationship with the miles per gallon that car gets. So let's make a plot looking at that relationship. We're going to start off with the ggplot function, and the first thing we need to tell the function is the data that we're going to be using. In this case, it's the empty cars data that we imported. Next, I need to tell the function what variables I want to see, and in this case, it's going to be the weight of the car, which is called WT, and the miles per gallon of the car. Now, we could run this line of code as is, but this isn't a very interesting graph because there's really nothing there. In order to tell the graph how to plot, we need to add something called a geom. And in this case, I'm going to use something called a geom point in order to get a scatter plot. Now, when I run this, you can see my beautiful plot that does tell me there's a relationship between miles per gallon and weight. Basically, the heavier a car is, the less miles per gallon it gets, which makes sense. But the beautiful thing about ggplot is it's kind of like Lego bricks. You can keep adding things to your plot as you go. So for instance, say I want a regression line that quantifies the relationship between weight and MPG. I can add that to my graph by saying plus and then stat underscore smooth. This takes an argument called method equals LM, which is just a linear model. So this is going to add our linear regression line. When I go ahead and run that, you can see that our regression line appears on our plot. And we can just keep adding things. Again, it's like Legos. We can just keep stacking them on top of each other. So for instance, let's say that I want to see this plot, but I want to see a plot for each level of gear that we have in our data set. I can do that by saying plus facet underscore wrap, and then giving it tilde, and then the variable that I would like to facet by. In this case, it's just called gear. When I run this plot, you can see that we get out that same plot, but now we have a separate one for each of our different variables of gear. And this is great, but we can add even more. Say I want each of my plots to have different colored dots and lines. If I go into my code inside this little AES function, I can tell it that I would like the different dots and lines to be different colors. The way that I do that is by using the color argument. This color argument says whatever variable I give it, make sure the colors are different for each level of that variable. So here I'm going to say gear. This means that each gear is going to get different colored dots and a different colored regression line. I can go ahead and run that, and you can see our beautiful plot. Now, one thing to note is that if we look at the legend right here, it seems like Python thinks that gear is a continuous value when we can see very clearly that it's a categorical value. If we want Python to know that this is a categorical variable, one thing that we can do is we can go into this color argument and we can say the word factor parentheses and put that around the variable that we want Python to know is a category. Now, this might look a little weird to have a function inside of a string, but this is indeed how we tell Python that a continuous variable is actually a category. And when we run it, you can see that the colors change from a continuous color palette to a discrete one, which shows that Python now knows that these are actually categories. Now let's take a look at the nuts and bolts of how to build a ggplot using plot9. We're going to use the penguins data, so I'm going to go ahead and load that in using pandas, and then let's look at the head of the data. So we can see that this data set has a variety of different variables, from the species of penguin to the island that penguin is from, and a bunch of different measurements from the body of the penguin. So there's a couple of steps to building a ggplot. The first thing you need to do is in the ggplot function, I'm going to put my ggplot function here, and let's talk about what goes in it. The first argument in the ggplot function is going to be a data frame where our data is stored. So for us, that's going to be penguin. The next argument actually takes in a function, the AES or aesthetics function. This allows us to tell Python what variables it is that we want to appear in our graph and how. For instance, in this case, I want X to be the bill length in millimeters, and I want my y-axis to be the bill depth in millimeters. I'd also like to color any of my geoms that I add by species. So I'm going to add color equals species. So again, the ggplot function tells Python what data to use, and from that data, what variables are going to appear in our graph. But like before, when we run this, we don't really get anything useful. You can see all the labels of our x-axis and our y-axis, but there's not actually anything appearing on our graph. That's because we need the second step. We need to tell ggplot how to plot our data. We've told it what to plot, but not how. So I'm going to go ahead and copy and paste this into the next cell. Now that we've told ggplot what to plot, we need to tell it how, and the main way we do that is with geoms. Geoms are basically different types of graphs that we can add. So in this case, I think I'd like a scatter plot of the bill length of a penguin and the bill depth, so I'm going to add a geom underscore point. Now, when I run my plot, you can see that we not only get that background we got before, but we also actually get a plot. ggplot now not only has information on what we want to plot, but how. So let's make another graph. Again, we need to start off with telling ggplot what we would like to plot. So I'm going to use the ggplot function and again give it the penguin data frame. Inside my aesthetics function, let's make a histogram of the body mass of the penguin. So I'm going to say x equals body mass in grams. And again, these are just the names of the columns of the variables that I'd like to work with. Now, because this is a histogram, we don't have any other variables that are involved. So we could just run this, and again, we would get an empty graph. This is not really useful, but at least you can tell that ggplot knows what we would like to plot, even though it doesn't know how to plot it. So again, I'm going to copy and paste this because I've already told it what, but now I need to tell it how. To do that, of course, I'm going to add a geom. In this case, instead of a geom point, I'm going to use a geom histogram. Now when I run this, you can see that I have a beautiful histogram of all the body masses of my different penguins. Okay, so let's do another one. This time I want to know about the different species of penguin in my data set. So I'm going to build a ggplot, I'm going to give it the penguins data set, and then inside my aesthetics function, I'm going to say x equals species. This is because I want the species of the penguin to be on the x-axis. Now, like before, I can go ahead and run this, but this is a pretty useless plot because I've told ggplot what to plot, but not how. So let's copy and paste, and let's tell ggplot how we would like to plot. Now, in this case, I want a bar plot. I basically want to know how many penguins in our data set are from each species. So to that, I'm going to add a geom, and in this case, I'm going to add a geom bar. Now, when I run this, I actually get a bar plot. All right, let's make one more plot before we get into some of the more fun features of ggplot. So as usual, I'm going to tell ggplot what to plot. I'm going to use the ggplot function and the penguin data frame. And inside my aesthetics, I'm going to say x equals species, just like before. And in this case, I'm going to say y equals bill length in millimeters. Now, when we run this, as usual, we're going to get a very useless graph because we've told ggplot what, but not how. So let's copy and paste that. And let's add the how. So of course, I'm going to add a geom. And in this case, I want to know the bill lengths of my penguins by species. So I think I'd like to use a box plot for this. When I go ahead and run this, you can see that we get a box plot. In fact, we get 3 box plots, 1 for each species. Now, when we read a box plot, the middle line is the median. So this is the middle value for our penguin bill lengths for each species. So for instance, we can see that Adelie penguins have a lower median bill length compared to the other 2 species. This white rectangle tells us where the middle 50% of the data is. while the whiskers tell us where the bottom and top 25% are, respectively. In a box plot, sometimes you'll see individual points. These are considered outliers, and these are things that are pretty extreme values on either end. All right, you've sat through a bunch of boring plots. Now let's talk about what we can add to make our plot a little more interesting. Remember, ggplots are just like Lego bricks. We can keep adding things to our plot. So what I'm going to do is I'm going to copy and then paste this code into a new cell. Now, this graph already looks good, but let's add a little pop of color to it. In this case, I want the boxes in my box plot to be different colors, one per species. In order to do this, I'm going to go into our AES function and add the fill argument and set it to species. This means the different geoms are going to be filled with different colors, one for each species. When I run this, you can see that we get pretty much the same exact plot, except we also get a filled in colorful box plot. But that's not all we can add. So let's copy and paste the code for that plot here. Another thing I might want to change is the theme of the plot. A theme is just basically a set of different aesthetics that make your plot look a certain way. For instance, the default theme is theme gray, and you can see that it has different features like a gray background. But let's say I'm looking for something a little different. I personally don't always love a gray background, so I'm going to add a plus theme underscore minimal. When I run this, you can see we're going to get the exact same plot, but now I have a different theme. Theme minimal is one of my favorites because I think it increases the contrast and reduces the amount of unnecessary ink that you have in your data visualization, but it's not the only theme we can try. For instance, another favorite of mine is theme classic. If we change this minimal to classic and rerun our plot, you can see again we have the same plot with slightly different aesthetics. And again, ggplots are like Lego, so we can keep adding things as much as we want. For instance, I really like my plot, but I would like to see my individual data points. Well, I can add that. One way I can do that is by adding another geom. I'm going to say plus geom point. And when I run this, you can see that we get points on top of our box plot. So I really like my plot, but notice that these points are also filled with different colors, one for each species. This is because we set the fill aesthetic in our general ggplot function. This means that that will apply to every single geom that we add to our graph. But let's say that I only want it to apply to the box plot, but I want all my points to just be a single color. In order to do that, I can delete this fill argument from our general AES and add it specifically to the geom that I want to have it. In this case, I want the box plot to have the fill aesthetic, but not the point. So inside my geom box plot, I'm going to say AES, and I'm going to say fill equals species. Now, when I run this code, we're going to get the same plot, but notice that the fill aesthetic only applies to the box plot and not to the other geoms. All right, let's make some slightly fancier plots. I'd like to make a bar chart where the height of the bar tells me the average body mass for the different species of penguin. Well, in order to do that, I of course have to start with a ggplot function. Inside my aesthetics function, I'm going to say x equals species and y equals body mass in grams. Just to make it a little prettier, let's also add fill equals species so that each of our bars is a different color. All right, so now we've told ggplot what to plot, but not how to plot it. So let's go ahead and add a geom bar and let's run. Oh no, we've got an error. This is because by default, geom bar expects the y-axis to be the count, so the number of penguins in that species. However, we want something a little different. We want the height of the bar to represent the average of another variable, like the body mass of the penguins. Instead of geom bar, we're going to use something called a stat summary. Stat summary allows us to calculate summary statistics from our data and then use that in our plot. In this case, we want it to be the mean. So we're going to use the argument fun underscore data equals mean SDL. This tells ggplot that we'd like to calculate the mean and standard deviation of our body mass. Next, of course, we need to tell it how we would like it to display this information. In this case, we'd like a bar plot. So we're going to say geom equals bar. Now when we run this, we get our beautiful bar plot as expected, where on the x-axis we have species and the height of the bar represents the body mass or the average body mass of the different species. Here we can see that Gen 2 penguins are the biggest penguins in this data set. Now, just to show you it's possible, I've copied and pasted this code that has the same plot but changes the aesthetics. You can see that now we have an even clearer, more beautiful plot, and we'll talk a little bit more about all of these changes in the next lecture. Now, that's not the only way to make this type of bar chart. One thing that we could do is, instead of using the stat summary function, we could actually just calculate those values ourselves and then use that in our ggplot. Let's make a similar bar plot, but we'll look at the bill length of the different species of penguins. In order to do this, I'm going to create a new data frame. I'm going to call it penguin_bill. And I'm going to use some of our pandas functions to calculate the average bill length for each species. First, I'm going to take our penguins data frame and group by species. I'm also going to set this as index argument to false, and you'll see why in a second. This is going to take our data frame and group it by the different species of penguin. Next, I'm going to grab the bill length in millimeters from that grouped data frame, and I'm going to say .mean so that I get the mean bill length. Now let's just take a look at what we've created. And you can see that we have a very small data frame where one column is species and the other column is the average bill length for that species. By the way, this as index equals false just basically allows us to have an individual column with the species instead of it being the row number. Now that we have this new summary data frame, we can actually just use that data frame in our ggplot. So let's build a ggplot and give it penguin bill as our data frame. In our AES function, we're going to say x equals species, y equals bill length, and these are just the names of the columns in our data frame. And then let's also do a fill equals species just to make it pretty. Now, as usual, I've told ggplot what to plot but not how, so let's add a geom bar. And we're going to need a new argument in geom bar. Again, geom bar assumes that the y-axis of our bar plot is just going to be a count, but in our case, it's not. It's going to be the values in the bill length column. In order to do this, we're going to have to use the argument stat equals identity. Now I'm just going to add a theme minimal, and then I'm going to go ahead and add some labels. We'll talk about this more in the next lecture, but this basically tells us what the label of each axis should be. All right, let's go ahead and run. And now we have our beautiful bar chart. Again, this is very similar to the stat summary way we did before, but here we just pre-calculate a data frame and then plot it using a geom bar. But that's not the only type of bar chart we might want to plot. For instance, here I'm loading in some data that rates different books that I've read. Here we see something really similar to before. We have a column of different items and then a value that we would like to have as the height of the bar chart. I'm going to start with my ggplot function and I'm going to say book df AES x equals books because that's the column that I would like on the x-axis. Then I'm going to say y equals ratings. And just to make it look pretty, let's do fill equals books as well. Now we've told ggplot what to plot, but not how, so let's add a geom bar with stat equals identity. Now I'm just copying and pasting some aesthetic changes like a theme and some labels. We'll talk more about how to do those in the next lecture. So when I go ahead and run my plot, you can see that we get this beautiful plot that shows us the different ratings for the books that I've read. All right. Enough penguins. Let's look at a new data set. We are going to load in this serial data set from GitHub and look at the head. We can see there's a bunch of different variables, so let's explore. All right, so I've written out the first plot for you. Here we're using our ggplot function to tell Python that we're going to use the serial data set and we would like to plot the manufacturer of the cereal on the x-axis. Then we're telling Python how to plot by saying geom bar, and we're adding an aesthetic fill equals manufacturer. That will make sure that each bar for each manufacturer has a different color. And last but not least, we're adding a theme. Another good one is the black and white theme, so I'm adding theme BW. When we run this, you can see we get our plot with all of the changes that we made. Now let's look a little bit closer at facet wrap and facet grid, which we actually used earlier. Let's say I want to know the relationship between protein and sugar in the different cereals, but I want to know if that relationship is different for different manufacturers. Let's start with a baseline plot. If I didn't even care about manufacturer, how would I plot this? Well, protein and sugar are both continuous values, so I'd probably use a scatter plot. So let's build that. I'm going to start with my ggplot and use the serial data frame. Then inside my AES function, I'm going to say x equals protein the name of the column, and y equals sugar. Now that I've told ggplot what to plot, I'm going to tell it how by adding a geom point so I can have a scatter plot. Of course, I want to add a theme, so I'm just going to add theme BW here. And let's go ahead and run. So this is a beautiful plot and tells us the relationship between protein and sugar, but it doesn't tell us if this relationship is different for different manufacturers. In order to do that, we're going to add a facet wrap. Facet wrap says make this same plot that we just saw, but make it once per manufacturer. In order to tell it that I would like it to make a group per manufacturer, I'm going to use the argument tilde MFR, where MFR is the name of the column that has the categories I want to facet by. Now when I run this, I get the exact same plot, but one per different manufacturer. And last but not least, let's just explore the sugars by manufacturer alone. To do this, I'm going to say ggplot cereal AES, and let's say X equals manufacturer and Y equals sugars. I want to know how much sugar is in the cereals for different manufacturers. So I'm going to use a box plot because a box plot is great when one of your variables is categorical and the other is continuous. So I'm going to say plus geom box plot. And then of course, let's do a theme minimal. All right, let's go ahead and run. And you can see that that's exactly what we get. So for instance, I think K is Kellogg's. They seem to have a wide range of amounts of sugar, from very low sugar cereals to very high sugar cereals. All right, that's all I have for you. I will see you next time.